All right, so we've talked about product to sum. Now we're talking about sum to product, which I bet you can guess goes the other way, right? If we have sine of one thing plus sine of another, or a difference, right? Cosine of alpha minus cosine of beta, difference of sines, or sum of cosines. So remember, these are different than the original equations that we talked about because those it was sine of alpha minus beta, right? One sine expression. Now we have sine of one thing plus sine of another. Okay, so we can see it's almost like we're averaging them out, kind of. So here's again, we'll just quickly talk about how we derive them. You don't have to recreate this. If we let alpha plus beta and alpha minus beta, we're going to let alpha be this thing, u plus v over 2. Beta is u minus v over 2. Okay, if we add those together, we have a common denominator. The v's cancel out. We have 2u, and it's just equal to u. How about if we take the difference between them? If alpha is u plus v minus u minus v over 2, we're going to get 2v over 2, and this is going to equal v. All right, so we will use this. We know that when we have a product, this is from the last section, the product to sum. Okay, so we're going to start with that. So we're going to say sine of u plus v over 2 times cosine of u minus v over 2. This is our alpha, this is our beta. This is equal to 1/2 sine of u plus sine of v, right? This u is our alpha plus beta and our alpha minus beta that we figured out here. So we multiply both sides by 2, and we get this equation here. Okay. Again, you don't need to know where that comes from. You can just use these equations that you will always have access to. Let's look at some examples. Sine of 4 theta minus sine of 2 theta. So we have sine of one thing minus sine of another, right? So we're just going to use this equation. Here's our alpha. So sine of 4 theta minus sine of 2 theta. We're going to use this equation here. So 2 sine alpha minus beta, so 4 theta minus 2 theta all over 2, times cosine of 4 theta plus 2 theta all over 2. All right, so this is going to be 2 theta over 2. And this is going to be 6 theta over 2. So we can simplify that as 2 sine theta cosine 3 theta. That's it. We've gone from a difference to a product. Okay. What about this one? Let's try to evaluate cosine of 15 minus cosine of 75. Well, we don't really know what cosine of 15 or cosine of 75 is. We could figure them out, but what if we used this and we said cosine of one thing minus cosine of another? So cosine of 15 minus cosine of 75 degrees. We can say, well, this is our alpha is 15 and 75 is our beta. So let's apply this equation. We get minus 2 times sine of alpha plus beta, that's going to be 90 over 2, times sine of alpha minus beta, so that's going to be minus 60 over 2. Right? Okay, so minus 2 sine of 45 times sine of minus 30. Those are degrees. Okay, well, sine of 45 is square root of 2 over 2. And sine of negative 30 degrees, well, let's see, sine of 30 degrees is 1/2. And negative 30 is going to be in quadrant 4, which is going to make it negative. So negative 1/2. So let's see, these cancel, and we'll have negative square root of 2 over 2. Is that right? Oh, look, we forgot this minus here. So minus times minus is going to be plus. We forgot that minus. I forgot the minus out front. So these multiplied together is going to be positive square root of 2 over 2. All right, so let's do one last one. Proving last two. Let's prove some identities. Cosine of 4t minus cosine of 2t all over 4 sine of 4t plus cosine of 2t equals negative tangent t. Let's start with the complicated side. We've got a difference in a sum. So let's look at our equation sheet. Cosine of alpha minus beta. Let's look at this equation here. Let's replace the numerator with that. So we're going to have minus 2 sine alpha plus beta over 2. So 4t plus 2t all over 2 times sine 4t minus 2t all over 2. Right, that's my numerator here. The whole thing divided by sine of one thing plus sine of another. So I'm going to use this equation here. So let's see, it's going to be 2 sine 4t plus 2t. Oh, wait, sorry, I'm looking. Yeah, 4t plus 2t all over 2 times cosine alpha minus beta. So 4t minus 2t all over 2. Right, so I'm like literally just plugging into these equations. And now let's see, these 2's are going to cancel. This is going to cancel too. So this is going to give me minus sine of 2t over 2 divided by cosine of 2t over 2. Well, I could write that as minus sine of t over cosine of t, which is negative tangent of t, which, hooray, that's what we're trying to show. Okay, so there wasn't anything clever. We were just plugging into these equations, right, and figuring out. The only thing you have to be careful of is what is your alpha, what's your beta. All right, let's do one last one. Let's verify this identity. Cosecant squared of theta minus 2 equals cosine of 2 theta over sine squared theta. I'll be totally honest. I didn't look at the answer. I'm not really sure how to do this. I can see a bunch of different ways that we could go about this. We could write this as 1 over sine squared. And maybe we should do that. So it looks like, I mean, here we have a double angle. We're going to have to deal with that at some point. We maybe could use a power reduction. I'm going to start by writing this in terms of sine and cosine. So I'm going to write this as 1 over sine squared theta minus 2 equals cosine of 2 theta over sine squared theta. Okay. All right, so now I'm going to multiply both sides by sine squared. I'm going to multiply everything by sine squared. So this term is just going to become 1. And here I get 2 times sine squared theta equals cosine of 2 theta. Okay, well, cosine of 2 theta, let's look at our angle sheet. So this is like an example of bringing this all together. This obviously isn't like a sum to difference or difference to sum. Cosine of 2 theta is one of these 3 equations. Oh, look, there it is, 1 minus 2 sine theta, or 2 sine squared theta. There we go. Okay, so how did we solve this one? We wrote everything in terms of sine and cosine. That made it a little bit more clear that I should multiply both sides by sine squared. There's probably other orders that you could do things in to solve that, show that identity.